Today's lesson is a bonus section for 9.5, so I put a plus there. This is a kind of a review thing from Algebra 2 that we're going to use a part of this to help us be able to do what we're going to do in the section 9.5, which is called the cross product of two vectors. And so we kind of use determinants to help us to do that. So let's review what a determinant is. So remember, the determinant of a 2 by 2 matrix, and these are matrices, where we have 2 rows, 2 columns, is going to be kind of like the cross multiplication, but then we subtract those. So we take the A times the D and we subtract it from the B times the C. Okay? You get AD minus BC. So if I was just evaluating the determinant of matrix A, where matrix A is 6, negative 3, 2, 3, okay, then that means that I would take 6 times 3 minus 2 times negative 3. Okay? So that gives me 18. Negative 2 times negative 3 is positive 6, so that gives me a positive 24. Okay? And so that would be a determinant. It's one number value for the matrix. Okay? Remember that for determinants, we use those in matrices to help us kind of find inverses of our matrices and then be able to figure out the identities. Okay? Or to show that two matrices are identities. Okay? So here, I want to also be able to do a 3 by 3 matrix. This is the main part. Okay? We just need to review the 2 by 2s because the 2 by 2s are in the 3 by 3s. So if I'm looking for the determinant of a 3 by 3 matrix, okay, now that means you have 3 rows and 3 columns. This one's a little bit more hands-on. Okay, so what we first do is we pick a row or a column. It doesn't matter which row or column you pick. Okay, I think usually when we do cross products, we'll pick the first row because it just makes more sense, and you'll see why when we do cross products. But for right now, when you're doing 3 by 3s, it doesn't really matter when you take the 3 by 3 because any row or column is going to set you up and you're going to get the same value for the determinant no matter what you do. Okay, so first things first, pick a row or a column in your 3 by 3. Okay, these numbers, or the 3 numbers that you picked, are going to be your cofactors. Okay, now cofactors are numbers in front of the breaking up. So let's look at a matrix. Okay, so like looking at this one, let's say I pick the middle column here, 1, 0, 1. Okay, these are my cofactors. So what this column does is it breaks up the rest of my matrix and helps me create different 2 by 2 matrices so that we can find the determinant of those using the AD minus BC thing that we just talked about. Okay, so these are like the numbers or like the coefficients that you put in front of those multiplications to help you get the determinant of a 3 by 3. So for this row, that's what we picked, okay, and that's what we're going to multiply. The step 3 is we need to attach the proper sign to each cofactor based on the location in the matrix. So if you look at this, okay, now each position in the 3 by 3 matrix, when you pull out them from your matrix for the cofactors, they have a certain sign. So since I picked this middle column, or the second column, then that means that my values are going to be minus, plus, minus. So I'm going to attach a negative sign to the 1 in that position. So 1 is in that spot in my matrix, so it would be a negative 1 instead of a positive 1. 0 will be plus, which it wouldn't have mattered either way if it was a minus or a plus for that one. And then the last one in that column is a 1, and so that should be negative, so it would be a negative 1. And we do that no matter where we pick them. Okay? So if we pick the first row, it would have been plus 1, minus 1, plus 1 for this particular matrix. Okay? The reason, and now you'll see, there's a particular thing to make this shorter, a little hint, is if your matrix has zeros, you should pick a column or row that has that 0 in it, and then that makes your determinant calculations less daunting, because the zeros like take care of some stuff for you, okay? Because you actually multiply a determinant, a 2 by 2 determinant, by 0, which is just 0, so it makes it less work, okay? So let's do this determinant, okay? Because number 4 is just evaluate. So if I pick this column, so for this one, like I said, -1, so I attach the negative sign to my first cofactor, and then what happens is, and I'm going to use different colors, so for this first one, purple, like since my 1 is in this column, I block out this column, and I block out the row it's in as well, okay? So I'm getting rid of some numbers. That creates kind of a 2 by 2 matrix feel, okay? Where the only number you are left with 4 numbers basically in a 2 pattern, right? So there's 2 in each row and there's 2 in each column. So that's the one that you take the determinant of, that AD minus BC. So here we would take 2 times 3 minus 0 times 5, okay? And that would be the first one. Then the next one, let's do this one. Okay, so the 0 is the next one. I said it's in the plus position, since this is in the middle. So plus 0. And now let's put green, so that crosses out that middle column and the middle row. But then, actually, let's go back. Let's rewrite this, okay? So make it easier for you to see. Okay, so here if I block out the column zeros in and the row zeros in, that leaves you with 1, 1, 0, 3. So then it would be 1 times 3, okay, and then minus 0 times 1. Okay, and then the last one, it will be the 1. So 1 is in the negative position, so I do -1. Okay, and let's create another one so you can kind of see this one as well. Okay, so let's put this one in orange. So 1 is in that middle column, and then the cross out the bottom row. So then it leaves you with 1, 1, 2, 5. So 1 times 5 minus 2 times 1. Okay, so then that's how we get those like submatrix, like 2 by 2s, because of the values you picked and then crossing them out. And do the same thing no matter what row or column you did. You'll always have 2 numbers above each other, like 2 sets of columns and 2 sets of rows. So you always get a 2 by 2. Because you're canceling out a column and a row at the same time because of the position of the cofactor that you're talking about. Okay, so now I want to multiply, so 2 times 3 is 6, minus 0, and then 0 times all of that is just 0, so that's where I said the easy part is in that. Okay, and then minus 1 times 5 minus 2. Okay, here -1 times 6 plus 0, and then -1 times 3. So -6 plus 0 minus 3 gives me -9. Now, just to prove that it doesn't matter where I pick my row or column, let's do another one. So I see a 0 in this bottom row, so I'm going to do that one. Okay, I'm going to pick 0, 1, 3 as my cofactors. So if I go back to this top thing, it would be plus minus plus. So 0 needs to be in plus position, but remember it's just going to cancel anything out anyway. But you cross out the column and the row that it's in, and that gives you 1 times 5, and then minus 0 times 1. and then 1 is in the negative position, so I say -1, and then that cross out that column and row, so that leaves you 1 times 5 minus 2 times 1, and then 3 is in the positive position, so cross out that row and column, so it leaves you with 1 times 0 minus 2 times 1. Okay, so now doing your stuff, that first one's 0, so that goes away. -1 times 5 minus 2 plus 3 times 1, or sorry, 0. 0 minus 2. So then 0 minus, looks like 1. 1 times 3, and then plus 3 times -2. 0 minus 3 minus 6, which gives you -9 again. So we have two things that match. So that's what I'm saying, is that every time it's going to give you the same value no matter what you pick to start with. So let's do a different one. So here, let's just choose one. It doesn't really matter. Let's pick the first column, just to pick a different position, okay? So in this case, 2 is in a positive position, so it's positive, times, cross out the row and column it is in, so that gives you 2 times 6 minus 5 times 4, and parentheses 0 is in a negative position, so it's minus 0, and then cross out the row and column it's in, so 3 times 6 minus 5 times -1, and then -2 is in a positive position. Now remember, it doesn't make it positive, it keeps it the same, okay? So that's one key. So going back to kind of what I said, and maybe this was a little confusing, pluses mean keep the same, negatives mean make it different sign. It just happened those other ones just made them negative because they were positive to begin with, okay? So here it says negative, so then 3 times 4, and then minus 2 times -1, okay? And so then now 2 times 12 minus 20 minus 0, because that just goes away, minus 2 times 12 plus 2, okay? So here 2 times -8 minus 0 minus 2 times 14, okay? So that gives me -16 minus 0 minus 28, and that will give me -44, okay? They won't always be negative, it just so happens that this one, like the last two, have been, but that would be the determinant for this 3 by 3 matrix, okay? And have fun.